Welcome to the deep dive. Today, we're looking at Anders Celsius, and yeah, that name means temperature to pretty much everyone, but is that the whole story?
It really isn't. The Celsius scale is everywhere, obviously, but when you dig into the records, the biographical stuff, the scientific papers from the time, well, there's just so much more there. Our mission today is to get past the thermometer.
Right, uncover the full picture of this 18th century Swedish scientist.
Exactly, because he was involved in a lot more than just temperature scales.
Okay, so let's start at the beginning. Uppsala, Sweden, 1701. And he wasn't just anyone born there, was he? His family background is pretty remarkable.
Oh, absolutely striking. I mean, think about it. His father, Nils Celsius, was an astronomy professor. His uncle, Olaf Celsius, a famous botanist. And even his grandfather was a mathematician and an astronomer.
Oh, yes.
Well, science was the family business, you could say.
Wow, yeah. You can almost picture the dinner table conversations. Must have been intense.
Definitely. So that environment, it clearly pointed him down a certain path. And apparently he had a real knack for it early on, especially mathematics.
So he follows in the family footsteps, studies at Uppsala University, and by 1730, he's actually a professor of astronomy there himself.
That's right. So long before the temperature scale discussion, his focus was really up towards the stars. In fact, that same year, 1730, he published a pretty significant work. Let me get the Latin right. Nova Methodus Distantium Solis, a terra determinandi,
Which means?
a new method for determining the distance from the Earth to the Sun. So right away, tackling big astronomical questions.
Okay, so astronomy is his main thing early on. But he didn't just stick to planets and distances, did he? He got interested in other sky phenomena, like the aurora borealis.
Yes, the Northern Lights. And his work there with his assistant Olaf Hjorter was really quite pioneering for the time. He wasn't just describing them. He was looking for causes, for connections. And here's a key thing. He was one of the very first to suggest a link between the auroras and changes in the Earth's magnetic field.
Really? That early? Connecting this visible light show to an invisible force like magnetism? That feels like quite a leap.
It was a significant insight. And he backed it up with observations. He actually watched compass needles deviating, moving erratically, and noticed that the bigger movements happened when the auroras were stronger.
That's fantastic observation. So methodical. Did he publish this work?
He did. He compiled this huge collection, 316 observations of auroras made between 1716 and 1732. He got that published in Nuremberg in 1733. It shows just how dedicated he was to studying them systematically.
Now, around this time, he also started traveling quite a bit, not just staying in Uppsala.
Right, between 1732 and 1735, he went on this grand tour, essentially visiting the big European observatories, Germany, Italy, France.
Just soaking up the knowledge. Or is there more to it?
Oh, it was more than just learning. It was about connecting with the wider scientific community, seeing the latest instruments, exchanging ideas. And while he was in Paris, he got involved in a really important debate. He started advocating for measuring a meridian arc way up north in Lapland.
Okay. Measuring a piece of the Earth's circumference. Why Lapland specifically?
Well, it was all tied into this huge question about the actual shape of the Earth. Newton's theories predicted it should be slightly flattened at the poles, like an orange, maybe. Others still held to the idea of a perfect sphere. Measuring a degree of latitude near the pole and comparing it to one near the equator was the way to settle it.
Ah, the classic flattened Earth versus sphere debate. And Celsius didn't just talk about it, he actually went.
He did. He joined the French Academy of Sciences expedition to Lapland in 1736. It was led by Pierre-Louis Maupertuis. Must have been quite an adventure.
I can only imagine. Trekking around Lapland in the 1730s to measure the Earth. So what did they find?
They meticulously measured the length of a degree of latitude up there. And when they compared their results to similar measurements done in Peru, much closer to the equator, the results were clear. Newton was right. The Earth is an ellipsoid, flattened at the poles.
Wow. So Celsius was right there, hands-on, helping to prove the fundamental shape of our planet. That's huge.
Absolutely. And he wrote about it, too, in 1738, Observations on Determining the Shape of the Earth.
And I bet being part of such a high-profile, successful expedition didn't hurt his reputation back home.
Not at all. It gave him a huge boost. Suddenly, he had a lot more clout, with the government, with his peers. And that was really instrumental in getting the support and, crucially, the funding he needed for his next big project. A proper observatory in Uppsala.
Which he managed to establish in 1741.
Yes, the Uppsala Astronomical Observatory. And thanks to his travels, he knew exactly what kind of modern instruments it needed, and he managed to acquire them.
So he wasn't just founding it, he was equipping it properly,
Mhm.
making it a serious center for research.
Definitely. He used it to observe eclipses, stars, other celestial objects. He even came up with his own system for measuring star brightness photometry. He cataloged the magnitudes for about 300 stars using his method. Very systematic work.
Okay, so astronomer, aurora researcher, Earth shape measurer, observatory founder. We've covered a lot, and we still haven't gotten to the thing everyone knows his name for.
It's quite something, isn't it? All that, and then comes the temperature scale in 1742. He presented it to the Royal Society of Sciences in Uppsala. But here's the twist that often surprises people. His original scale. It was upside down compared to what we use.
Upside down. How so?
On his scale, 0 degrees was the boiling point of water, and 100 degrees was the freezing point.
Get at really boiling was 0. That seems counterintuitive now. Why set it up that way? Any idea?
The sources don't give a definitive why for his choice, but it's just fascinating that it was inverted, and it wasn't even him who flipped it.
So who did?
That seems to have been Carl Linnaeus, yes, the famous botanist. Apparently, sometime after Celsius died in 1744, maybe around 1745, Linnaeus suggested reversing the scale, 0 for freezing, 100 for boiling, the way we have it now. And only later was it officially named Celsius in his honor, using this reversed version.
That's a critical detail. So the scale we use is Celsius's concept, but modified by Linnaeus. It shows how science isn't always just one person's invention. It evolves.
Precisely. It's often collaborative, iterative. But the core idea, the 100-degree interval between freezing and boiling, that was Celsius's key contribution to thermometry.
Okay, so main claim to fame sorted, albeit with a twist. Did he dabble in anything else scientifically?
Yes, a couple of other things worth mentioning. He did geographical measurements for the Swedish general map, basically, helping to map Sweden more accurately. And he was also one of the first people to notice that Scandinavia seems to be slowly rising out of the sea. We now know it's post-glacial rebound.
Ah, the land bouncing back after the Ice Age.
Right. His explanation for why it was happening, something about water evaporating, was off, but spotting the phenomenon itself, that gradual uplift, was quite perceptive for the time.
And throughout all this, he seems to have been pretty central to the scientific community in Sweden itself.
Very much so. He became secretary of the Royal Society of Sciences in Uppsala way back in 1725 and held that post right up until he died. Plus, he was a big supporter of founding the Royal Swedish Academy of Sciences in Stockholm in 1739. He was one of the founding members.
Really involved in building the institutions of science, too.
He even suggested the name for the academy. It shows he wasn't just focused on his own lab work. He cared about the whole scientific infrastructure in Sweden.
So, summing up Anders Celsius, it's way more than temperature. It's astronomy, calculating the sun's distance. It's groundbreaking aurora research, linking it to magnetism. It's literally helping measure the Earth, founding a major observatory, being a key figure in Sweden's scientific societies, and, yes, also proposing that centigrade temperature scale, even if it got flipped later on.
That really covers it. You see how interconnected it all was for him? His travels fed into the observatory work. The Earth measurement gave him clout. He had a huge impact.
It really makes you think, doesn't it?
Yeah.
We use the Celsius scale every single day, checking the weather, cooking. It's so fundamental.
Yeah.
And yet it comes out of this incredibly rich background of astronomy, physics, exploration, and scientific collaboration.
Which leads to a final thought, perhaps, for you listening. Think about other simple tools or units we use constantly. Kilograms, meters, seconds, even things like maps. How many of them have similarly complex, surprising histories, born from centuries of curiosity, debate, and discovery by people like Celsius? It's easy to forget the depth behind the everyday.